What if a rock older than our sun quietly slipped through our solar system, whispered something no one expected, and vanished before we could understand what it just told us? Because that is exactly what happened, and most of the world was too distracted to notice. Before I take you deeper into this, do me one small favor. If space, science, and stories that quietly shake the way you see the universe are your kind of thing, hit that like button, subscribe, and share this video with one friend who still looks up at the night sky and wonders. That single click helps more than you know, and it lets me keep bringing stories like this to you. Now, let me take you back to a quiet morning in Chile, July 1st, 2025. A telescope built to hunt for asteroids that might one day threaten Earth was doing its usual scan of the sky. Nothing dramatic, just another night of patient watching. And then a faint smear appeared on the screen. Small, fast, strange. At first it looked like just another distant rock. But when the software calculated its path, something did not add up. The object was moving too fast. Way too fast. Faster than anything that belongs to our sun. Faster than any comet, asteroid, or planet we have ever tracked in our own solar system. Its speed was around 221,000 kilometers per hour, and that number alone was enough to make astronomers stop and stare. Because when something moves that fast on that kind of curved path, it means one thing. It is not from here. Within a day, the news started spreading in astronomy circles. Within 2 days, telescopes on almost every continent were being adjusted, redirected, requested. Within a week, every major observatory on Earth and every powerful telescope floating in space had turned its eye toward this one small visitor. It was named 3I Atlas, the third interstellar object ever recorded in human history. And from the very first observation, it started breaking expectations. To understand why this moment felt so big, you need to understand something simple about space. Space is not empty. Between the stars, between the galaxies, there is drifting debris, broken pieces from long-dead planetary systems, frozen chunks of rock and ice that were flung out billions of years ago when giant planets shifted around and tossed smaller bodies into deep space. These objects then wander alone for billions of years, silent, cold, untouched. In theory, thousands of them should be passing through our solar system all the time. But in practice, we almost never see them, and they're small, dark, and moving too. Fast for our instruments to catch. That is why every interstellar visitor becomes a global event. The first one we ever caught was in 2017. It was called Oumuamua. It looked like a strange, long, tumbling shard. It had no visible tail, no dust cloud, no gas leaking out. But somehow it was speeding up in ways that gravity alone could not explain. Some scientists said it was a hydrogen iceberg. Others suggested a very thin natural sail pushed by sunlight. And one Harvard astrophysicist, Avi Loeb, went further and asked a question that split the scientific world. What if it was not natural at all? What if it was a piece of alien technology? Most scientists rejected that idea. But no one could fully explain Oumuamua either. And before we could study it more, it was gone. Then, in 2019, came the second visitor, Comet 2I Borisov. This one looked much more familiar. A proper comet with a tail, a coma, and normal chemistry. It was interesting, but not shocking. Scientists studied it, learned from it, and moved on. 2 visitors. 2 very different personalities. And then came the third one, and everything shifted again. 3I Atlas was moving faster than either of them, much faster. And in the world of interstellar objects, speed is not just speed is time. The faster an object is moving, the more likely it is that it has been thrown across space with enormous force, and the longer it has probably been traveling. Its path suggested it came from the thick disk of the Milky Way. This is the older, puffier part of our galaxy where most of the stars are ancient. Some of them are older than our sun by billions of years. That single detail became the first quiet warning sign. This object was not just from another star system. It might be from a much older era of the galaxy. An era before our solar system was even a thought in the universe. And once astronomers realized that, the pressure was on. Because interstellar objects do not stop. They do not orbit. They do not return. They pass through, warm up briefly in the sun, release whatever secrets they carry, and then vanish forever. If we missed this one, we would never get another chance to study this exact traveler. Ever. So they moved fast. Hubble was the first big space telescope to lock on. On July 21st, 2025, it captured a clear image of 3I Atlas when the comet was around 277 million miles from Earth. The picture showed a soft, teardrop-shaped cloud of dust glowing around a solid, icy core. But the size of that core was hard to pin down. Estimates went from about 440 meters to over 5 kilometers wide. That is a huge range. But when you're trying to measure a small dark nucleus hidden inside a bright, glowing cloud, that kind of uncertainty is normal. Later observations narrowed it down. By early 2026, the nucleus was estimated to be about 2.6 kilometers across. Think about that for a second. A frozen rock the size of a small city, drifting through space for billions of years, silently traveling from one part of the galaxy to another, finally passing close enough to us that we could look at it directly. And we did. Hubble looked, James Webb looked, the European Space Agency's JUICE mission looked, NASA's Lucy mission looked, Mars orbiters looked, ground-based giants like the Very Large Telescope, ALMA, and Subaru looked. It was as if humanity briefly turned every eye it had toward one tiny frozen visitor, and what we saw did not match anything we had seen before. The first strange detail was its speed relative to the Sun, around 60 kilometers per second on its interstellar path. This suggested that whatever star system it came from had thrown it out with enormous force, probably a gravitational slingshot from a giant planet. Imagine a massive world, many times the size of Jupiter, pulling on this small object, whipping it around, and then flinging it into deep space so hard that it never stopped moving. That launch happened so long ago that we cannot even begin to guess which star system did it. That star may not even exist anymore. But the real shock came when James Webb turned its chemical eye on it. Because Webb does not just take pictures. It reads the fingerprints of molecules. It can look at a comet and tell you what it is made of, sometimes down to the isotope. And what it found in 3I Atlas was unlike anything we had ever measured in a comet. Ever. Before I go into the chemistry, take a quick pause with me. If you're enjoying this story so far and want more deep dives like this on your feed, tap that like button one more time and drop a comment with just one word. Whatever word describes how you feel right now. Curious, amazed, nervous, speechless? That single word helps this video reach more people who love the sky the way you do. Now let's keep going, because this is where the story starts to feel almost impossible. Webb's instruments showed that 3I Atlas was carrying extremely high levels of deuterium. Deuterium is a heavier version of hydrogen. Comets in our solar system usually carry a small amount of it. That is normal. What is not normal is what Webb found. This comet had roughly 30 times more deuterium than the comets we have in our solar system. Not 30% more, 30 times more. That is not a small difference. That is not a measurement mistake. That is a completely different chemical world. When scientists see numbers like that, they know they are not looking at something that formed in our neighborhood. They are looking at something that formed in a very different place, in very different conditions, at a very different time. And the time part was the biggest shock. Researchers estimated that 3I Atlas may have formed between 10 and 12 billion years ago. Let that number sink in. Our sun is about 4.6 billion years old. Earth is about 4.5 billion years old. The first single-celled life appeared on Earth around 3.5 billion years ago. When 3I Atlas formed, none of this existed. The sun was not a star yet. The material that would eventually build the sun was still scattered across space. The Earth was not even a rough draft. Life on our planet was not a possibility. It was not even a distant idea. This comet was already ancient before our world had begun. Two independent teams reached the same conclusion using different data. One team led by Martin Cordner at NASA's Goddard Space Flight Center worked with the James Webb data. The other team, led by researchers at the University of Edinburgh, used the Very Large Telescope in Chile. Different instruments, different methods, same answer. The results were published in the journal Nature in June 2026. The scientific consensus that emerged was almost gentle in its wording, but heavy in meaning. This object formed in the very early Milky Way. It is likely older than our sun. It is possibly older than the very neighborhood we live in, and it just floated right past our doorstep. In one interview, Dr. Cordner said something that stayed with me. He said this comet gives us insight into a distant time and place, but it also tells us something about how unusual our own solar system might be. That single sentence, said calmly, changes everything. Because if this comet is normal for the old parts of the galaxy, then our solar system is the strange one. Our chemistry is the odd one. Our formation environment is the unusual one. And that means the universe out there might be much more diverse and much more alive with possibilities than we assumed. But this was only the beginning of the strangeness. The next set of measurements pushed things even further. The comet showed unusually high carbon dioxide levels, low ammonia, that extreme deuterium ratio we already talked about, and an elevated carbon-12 to carbon-13 ratio. All of these clues together pointed to something remarkable. This comet formed in an extremely cold environment. Below 30 Kelvin, that is around minus 243 degrees Celsius. That is colder than anywhere in our current solar system. This means the region of space that gave birth to 3I Atlas was one of those quiet, deeply frozen corners of the early galaxy where molecules could form and freeze in place and then just sit there, preserved, for billions of years, untouched, undisturbed, like a message written in ice and locked inside a stone. And then, when the sun's warmth finally reached it in 2025, that ice began to melt, and it started releasing what it had been carrying all this time. That is what Webb saw. That is what the world watched. And then Webb saw something else, something that made the entire scientific community pause. Methane. Yes, methane on an interstellar comet. This had never been detected before on an interstellar visitor, not on Oumuamua, not on Borisov, only on 3I Atlas. And methane is not just another molecule. Methane is special. On Earth, methane is produced in two main ways. One is geology, volcanic activity, deep chemical reactions inside rocks, natural processes without any living thing involved. The other way is biology, living organisms, microbes, certain kinds of bacteria that live in places without oxygen. That is why methane is one of the molecules astrobiologists watch closely when they look for signs of life on other worlds. Not proof of life, never proof by itself, but a strong hint, a flag worth investigating. And here it was, showing up on a comet older than our sun. Water vapor, carbon dioxide, methane. All of it concentrated near the nucleus. All of it released, as our star gently warmed a rock from another era of the galaxy. If you were an astronomer that week, you probably barely slept. At this point, Avi Loeb from Harvard entered the conversation again. He had been watching 3I Atlas from the very beginning. And by his own count, he had listed more than a dozen features about this object that he considered anomalies. The strange trajectory that took it past several inner planets. Its unusual mass estimate. The way its jets seemed to line up with the sun in a very specific way. Its speed, its brightness, its behavior. Loeb argued that if this were a purely natural rock, the universe would have to be extraordinarily kind to us to line up so many rare features in a single visitor. He suggested that some of these features could, at least in theory, be consistent with the possibility of alien technology. To be very clear, this is not the majority view. Most scientists strongly disagree with him. NASA officials, including senior representatives, have said clearly that all evidence points to 3I Atlas being a natural interstellar comet. The CD Institute and Breakthrough Listen used the Allen telescope array to look for any artificial radio signals. They found nothing. No signals, no broadcasts, no structures, no technology. The official conclusion remained the same. A comet. An ancient, chemically strange, unusually old comet. But natural. And yet, the story does not stop there. Because underneath all of this debate, there was one deeper question that no one on either side could easily answer. That question is not whether this was a spaceship. That question is not whether there were tiny aliens sitting inside it. The real question is quieter, and in some ways, much larger. It is this. If the galaxy has been making chemistry like this for over 12 billion years, and if some of that chemistry is the same kind of chemistry that leads to life, then what does that mean for us? Stephanie Milam of NASA's Goddard Space Flight Center put it beautifully. She said that finding these rare isotopes is fascinating, but the bigger picture is looking at the possibilities of prebiotic chemistry elsewhere in the galaxy. Prebiotic chemistry. The chemistry that comes before life, the building blocks, the molecules that under the right conditions can slowly combine into amino acids, then proteins, then simple structures, then something that eats, then something that grows, then something that thinks. And 3I Atlas was carrying those building blocks. Methanol, hydrogen cyanide, carbon dioxide, carbon monoxide, water ice. These are not exotic. These are the same kinds of molecules scientists talk about when they discuss the ingredients that likely helped life begin on our own planet. And this comet was carrying them from the earliest era of the Milky Way, from long before our sun, from long before Earth, from long before anything we know. Now let me pause for a quick check-in with you. If your mind is doing that quiet flip where you suddenly feel very small and very curious at the same time, you are not alone. That is the exact feeling scientists were having in real time during 2025 and 2026. If this story is pulling you in, take a second to smash that like button and hit subscribe if you have not already. And if this video makes you feel something, share it in one chat with someone who deserves a break from the noise of the world today. Your share literally decides whether stories like this survive on this platform. Now back to the story, because it is about to take an even more unusual turn. Avi Loeb went one step further with his interpretation, but not in the direction most people expect. He did not just talk about spaceships. He talked about something older, stranger, and in some ways harder to dismiss. He talked about panspermia. This is the idea that life, or the seeds of life, can travel across space embedded inside comets and rocks. It is not a fringe theory. Francis Crick, the Nobel Prize-winning scientist who helped discover the structure of DNA itself, proposed a version of this idea decades ago. The core concept is simple. Life, once it begins somewhere, might not stay there. Small pieces of it, hardy microbes or the chemical seeds of life, could be picked up by ejected rocks and comets and carried across huge stretches of space. And when those rocks eventually land on other worlds with the right conditions, those seeds could take root. Loeb went further with the idea, suggesting the possibility of what is called directed panspermia. The idea that some civilization somewhere, at some time, could intentionally seed comets and send them across the galaxy toward worlds that could support life. He compared it to a dandelion releasing its seeds in the wind. He asked, out loud, in interviews, referring to the Webb data, "Is there any chance that this iceberg is carrying microbes? Is that possible?" That question, coming from a Harvard astrophysicist, referencing James Webb data, and pointing at real chemistry, is not a science fiction question anymore. It is a real scientific question. It might not have a comfortable answer. It might not have any answer at all in our lifetime, but it is now on the table. And 3i Atlas put it there. Then reality set in. Because no matter how many questions we had, the comet did not wait for us. It kept moving. It made its closest approach to Earth in December 2025. It swung past the sun, it heated up, it released its ancient chemistry into space. And by March 2026, it had crossed beyond Jupiter's orbit. By the early 2030s, it will have left the planetary region of our solar system entirely. And then it will continue, silent, back into the dark, never to return, ever. 12 billion years of traveling through the galaxy, 12 billion years of drifting past stars we will never see, 12 billion years of holding on to its chemistry through the deep cold. And this one brief moment when it warmed up in our sun and let us look inside was our only chance. We took the chance. We watched, we measured, we argued, we wrote papers, we asked questions we could not fully answer. And then we let it go. There's a strange kind of grief in that, a quiet ache. Because we finally had proof that something ancient and beautiful and possibly meaningful had come close to us, and we did not have the tools ready to grab a sample. No probe reached it, no lander touched it, no mission returned anything from it. We can look and we can listen, but we cannot yet chase. Not that fast, not that far, not yet. And this is the humbling truth. If there was a real quiet answer sitting inside 3i Atlas, we may not have been ready to hear it. Not in time, not with the right instruments, not with the right speed. That is the price of being a young civilization. We are still learning to build the ears we need to catch the messages the universe keeps sending. But at least we listened. At least we tried. The chemical signatures that 3i Atlas left in our records will be studied for decades. Scientists will keep unpacking every isotope, every spectrum, every ratio. Every paper published on it will feed into the next generation of interstellar object hunters. And they will hunt. Because 3i Atlas was almost certainly not alone. Astronomers now estimate that at any given moment, there is likely more than one interstellar object of similar size passing through our inner solar system. Most of them we never see. Most of them slip past silently. Most of them arrive, pass, and leave without any human ever noticing. So the sky above you tonight is not as empty as it looks. There are old travelers moving through it. There are frozen visitors carrying chemistry from parts of the galaxy that formed billions of years before our sun. There are messengers passing through, some of them carrying molecules that could, under the right conditions, become the beginning of something alive. And most of them are ghosts to us, invisible, silent, beyond our reach. 3i. Atlas was the rare one, the one we caught, the one we watched, the one that woke everyone up. And now let me sit with you in the strangest part of this entire story. Not the science, not the debate, not even the methane, the timeline. Think of everything humanity has ever done. Every civilization, every language, every empire, every song, every religion, every war, every love story, every quiet evening at home with someone you cared about, every scientific breakthrough, every book, every dream, all of it happened in a slice of time so thin compared to the age of this comet that it barely registers. When 3i Atlas formed, none of that existed. And when it passes another star billions of years from now, none of what we know will exist either. Yet, for one brief window, our timeline and its timeline crossed. It came close. It warmed, it spoke quietly in the language of chemistry, and we, a species just beginning to understand its own place in the cosmos, happened to be here, awake, watching, listening. That alone feels like a small miracle. Take a breath here for a second with me, really, because there is one more thing I need to ask you before we go into the final part of this story. If you have made it this far, you are the kind of viewer this channel is made for. So please give this video a real, not a lazy tap, and leave a comment telling me one thing. If a probe could bring back a piece of 3i Atlas, what is the first question you would want scientists to try to answer with it? Your answers genuinely inspire the next videos I make. Now let us finish this story the way it deserves. To end, here is what 3I Atlas ultimately taught us. It taught us that the galaxy has been quietly building icy bodies for far longer than we imagined. It taught us that some of those bodies are still wandering, right now, through space that we can see. It taught us that the chemistry needed for life is not rare and lonely. It is common. It is old. It is spread out across the galaxy in ways we are only just beginning to measure. It taught us that our solar system might be an unusual pocket in a much older, much wilder galaxy. It taught us that even the most ordinary night at an ordinary observatory can, without warning, become the moment humanity meets a traveler from a time before the sun. And it taught us something more personal, that we are not as isolated as we sometimes feel. The universe is not silent. It is not empty. It is not cold. It is full of ancient objects carrying ancient chemistry, drifting through space, patient, quiet, waiting to be seen by whoever happens to be watching at the right time. On July 1st, 2025, we were watching. We saw one. We named it 3I Atlas, and we let ourselves be humbled by it. It did not carry a flag. It did not carry a message written in a language we could read. It did not have blinking lights or clear signals, but it carried something more powerful than any of that. It carried time, 12 billion years of it, frozen in ice, preserved in molecules, delivered to our doorstep for a few brief months, and we, imperfect and unready, still managed to read a few pages of that story before it slipped away. Whether or not there was ever a microbe hidden inside its ice, we may never know. Whether or not it was seeded by some ancient civilization, we may never confirm. Whether or not it carried the first hint of extraterrestrial life through our neighborhood, no one can prove either way. And in a strange way, that is the most beautiful and haunting part of all of this. Not that we got a definite answer, but that a real, respected, careful scientific question was finally asked out loud, using real data from a real object in front of a real world. The answer to that question may take generations to fully understand, but the question itself is now unlocked. And it started with one small blur on a screen in Chile, one faint smudge that could have been dismissed, one quiet observation that grew into one of the most extraordinary encounters humanity has ever recorded. When you look up at the sky tonight, remember that. Somewhere out there, still moving at unimaginable speed, is a rock older than our sun. It came from a place we will never find. It is heading toward a future we will never see. And for a moment, our story and its story touched. Maybe that is what the universe does. Maybe it does not shout. Maybe it does not send obvious signals. Maybe it just sends quiet travelers through the dark, one at a time, hoping that someone somewhere is paying attention when they pass. On July 1st, 2025, we were paying attention. And that changed everything. So the next time you feel small under the night sky, remember that being small is not the same as being alone. The galaxy is old. The galaxy is patient. The galaxy is full of stories. And every now and then, one of those stories drifts close enough for us to catch a whisper of it. 3I. Atlas was one of those whispers. It came, it spoke, it left. And we are the lucky ones who happened to be here, awake, watching, when it did.